Hi everyone and welcome to our channel. Today we are going to see one of the data structures concept, which is nothing but single linked list introduction and insertion operation in single linked list. Now see the single linked list. The structure of single linked list will look like this. You can see here every node of single linked list will majorly have two parts. The first part is the data part, right? And you can store anything into the data part, whether it may be an integer, string, floating point, like that. Any primitive data that you want to store, you can store it. And the next part, we can call it as the address part, which means it holds the address of the next node. For example, see, let the this node address is 1000, this node address is 2000, this node address is 3000, right? These are just memory location addresses in my system. Now see, let the data be 10, 20 and 30 it was holding, and the next part of the first node will hold the address of the next node. Means what? It holds 2000, it holds the next address, next node address 3000, and the last node of the linked list will be holding the null. Okay, we need to get the starting node of the linked list, the start pointer, so that we can traverse the entire linked list by going next, 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 like that. We can able to traverse the entire linked list. Okay, now let me show you how to do the insertion operation in the linked list. See here the insertion operation. Insertion operation can be done in three ways. The first one is inserting at the beginning, the next one is inserting at the end, and the next one is inserting at the middle. Okay, now first see how to insert at the begin. Now let's see that we are having some linked list. Okay, like this, its content is some 20 and its content is 30, its address is some 1000, its address is some 2000 and 2000, right? So address will be here, and it is the last node, let it be, so it is having null. So if you want to insert at the beginning, how to do that? This is a start pointer, right? Now you need to make this pointer, to point here. Means you need to store this address, and the starting pointer should point here, right? Start will be here, so that you can see the updated linked list from starting until you will get 3 nodes. If you want to insert at end, what you will do, you will create a node like this, and you will take a temporary pointer and you will traverse like this. Once you reach at the last node, what you will do means, instead of storing the null, you will store this address. For example, this address is some 3000. Instead of storing null, you store this 3000, and then you will make this node's address value as null. So you can see the updated linked list 10, 20, 30, 40. Now let me tell you how to insert at the middle. Let's see how to insert at middle. Let me take in some linked list. What I need to do, let it be address as some 2500, like that. What I need to do is, it's a next address, means 2000, right? So it need to point here, and here it need to point here, right? You can see 10, 20, 35, 30, 40. You will get the data like this. Why? This is not pointing here. This link has been broken, and you can see the link has been established here and a link has been established here, so that we can see the updated linked list with the insertion at middle. Now by doing like that, by making the changes to the pointer, we can able to insert at begin, insert at end, and insert at middle. Okay, let's see each of these operation with programming support. Okay, let's see here. The first thing was, I need to take the node, right? Structure node. Let me take structure node, struct node, and then I need to take the data, right? I am going to take the integer data, so int data, and followed by a referential, self-referential pointer, struct node star next. Why? Because it needs to hold the address of the next node, and the next node of what type? It is also a node type, right? So that's why I taken like that. I taken the structure, and I need to take the structure variable, right? The pointer, the first pointer, struct node star, right? Hold a minute, star, start pointer, and it is going to hold the null value at the beginning. Okay, now see here, I'm going to take three methods. Let's see the three methods. The first one is what? Void insert at the beginning, insert at begin, and this is taking element to be inserted. Okay, let me take empty. Okay, initially again void insert at end, it is also taking an element to insert at end, and let me take it empty for time being. Void insert at middle, right? Hold a minute, insert at middle, and it is also taking the element, right? It also taking the element to insert, and these three functions will do the task of insertion at beginning and middle. Okay, in the main function, let me do the task. Let me first read the integer element to be inserted, and let me ask the user choice, okay, whether he want to insert at a middle or end, like that. Okay, let me write the first a printf message, enter element to insert. Okay, we will take the data. Hold a minute, we will take the data in the switch case. Okay, let me write like this first. Let me give the choices to the user. Okay, enter your choice. Okay, user will enter his choice, and let me give the choices. Okay, see, the first one is what? The first one is at beginning, right? Insert at beginning. Okay, the next choice is what? Let me put \t, so you will get a tab space. Okay, now let's see, the next one is insert at end. Let me put a \t. Let me give a third option as insert at end, right? At end, let me write \n. Okay, good. With this we can print a message. Now I need to read, right? Scanf %d ampersand of choice, integer element choice, right? So that's why %d. Now I read the choice, and I'm going to take the switch statement. Okay, before going to take the switch statement, I'm going to take it in the while loop. Why? Because I need to make this entire thing happen indefinitely. Okay, infinitely, right? Undefined number of times I want to repeat, so that's why I'm taking in while of 1, always true. Okay, let me remove this one and paste it here. You can see, now you can see every time this message will be printed and his choice will be taken. Okay, now let me write the choices. Switch off choice. What are the possible choices? Choice 1, 2, 3, right? So the labels will be case 1, the first one. Okay, print enter element to insert. Okay, I'm asking the user to enter the element. Right, now let me put a semicolon here. Once the user has entered the element, I need to read it, right? Scanf %d ampersand of element. I read it, means I stored in element variable. Once I read the variable, what I need to do? Hold a minute. Let me format it. Okay, I read it. Now I need to call the function, right? Function name is insert at begin. Begin of the element I need to pass as this one, and I will break the loop. That's it. Now again, let me copy this case. Let me paste one more time and one more time again. Okay, this is case 2, means enter element to insert. Again I read the element. Now this time I'm going to insert at end. Okay, second choice means insert at end. The third choice is what? Insert at middle, right? You can see insert at middle, insert at end, insert at begin. These are all the functions that we are going to take, and we are passing the arguments, and we will write the code for it, how to insert at the middle, everything. Okay, so let me change it to case 3, and let me take a case 4 to display the result. Okay, hold a minute. Let me take the case 4 to display the result. Let me put a backslash t. Okay, let me save up to this, and let me take the case 4. Okay, case 4 I'm going to take. In case 4 we no need to read anything, right? We can directly call the insert function. See, we can directly call the display function. Hold a minute. Display, we can call it directly, and let me write the display function here. Void display, right? The spelling is correct. Yes, display. This is the method. Now let me tell you, the reading has been done, and we are going to take up this method now. Okay, I will write the content how to insert at the beginning. Now I need to first allocate the memory, right? So let me take this header file, dynamic allocation, right? So what is header file I need to include? stdlib, stdlib.h, so that I can get access to mloc, cloc, realoc, like that, those functions. stdlib.h. Now let me create the structure. Struct node. Let me take the pointer star as nn, new node. Once I taken that, I'm going to cross check. First one is what? If start equal to null, the pointing start pointer is null, means what? There are no nodes in the linked list. If there are no nodes, then my inserting node will be the first node, right? So for that, nn equal to struct node star, and I'm going to take malloc function. Malloc, yes, malloc size of struct node, right? Size of struct node. This is the syntax, right? malloc size of the data type, and then you need to typecast. Why? Because malloc function will return the void pointer type. You need to typecast it. So struct node star malloc size of struct node. Okay, okay, struct node. Good. Now here I need to take the data, right? Data equal to element, right? Whatever the element you pass, you write it here, and then the next pointer will be null. Why? Because it was the first thing, and it was the only thing we are going to insert into the linked list. And then start equal to nn, right? This will be like that. There are new nodes, there are no nodes, right? So I will insert 10 like this, and nn is the pointer for it, and this next pointer is make as null, and start is also pointing to it. Like that you will get after executing this code. Okay, and let's see here. Now you can observe here, else if. Why I'm writing else if means, what if there is already a node is available and I want to insert at begin. You can see start next equal to null, right? Then if there is one node, start next equal to null. Start will not be null. Why? Because there is a node available, right? Now the same concept up to this. I'm going to take a new node, and then I'm going to assign the data to it, nn of data. Now what you need to do, nn of next, right? You can see this one. If there is already a node available, this is nn, right? This is our node. Nn of next need to point to that node, and the start again need to point here. Means start will be from here. Okay, let's see how to do that. Nn of next new nodes pointer will point to the start pointer, and the start pointer will start from newly created node. Okay, else means what? You are having more than one node in the linked list and you are trying to insert that, then also no problem, the same thing, right? Same thing you can write. Now let me copy and paste it here. The same thing. Why? Because if they have any number of nodes, if you are inserting at begin, you simply the newly inserted node next address will point to the starting address, and starting address will start from the newly created node. That's it. So that you will get the insert at beginning. Now let's see the insert at end function. Okay, insert at end means you need to traverse till end and you need to insert there, right? Now see, struct, hold a minute. struct node, I'm going to take star nn, and I'm going to take a temporary pointer p. Why? Because I need to traverse up to ending node, right? I need to know where is the end. So I need to take like that, and let me create the node. Okay, let me copy out from this one, and let me take the data. This is entire thing is same. Okay, I created a new node, and I had taken like this. I had taken a data into it. This is done. Now what I need to do, I'm going to insert at last, right? So the next value will be always what? Null, right? For a single linked list, always the last node's next value would be null. Okay, and then what I need to check, I'm checking here. If start equal to null means what? There are no nodes. If there are no nodes means what? Your inserting node will be the first node. Start equal to nn. That's it. Else if means, if you got a condition like this, start next equal to null means what? There is a one node available in the linked list, and you are going to insert your node after that node, means it will be like this. See, there is a node available here, start is pointing here, and you are created a newly node nn, and you need to form like this. How it will happen? Start next equal to nn, right? Then it will be done. See, start next equal to nn, start next equal to nn. That's it. You can get that. Okay, now let's see else statement. Here you need to write some code. Why? Because you need to start from the starting pointer, and you need to go until you find the last node. Okay, while p next not equal to null, you need to repeat this process. Whenever it has become null, hold a second, single statement, right? No need to take brackets also. P equal to p next means what? It will move on like this. See, if there are some nodes available, this is a node, this is a node like this, I want to insert a new node here. P will start from here, p next like this. Whenever it becomes null, you find it null, you will assign this next part to new node, so that the chain will be established, right? Link will be established. See, after coming out of this loop, you will get p pointing to the last node. So p next equal to nn. That's it. This code will do the insertion at ending. Okay, now we will see how to insert at the middle. Okay, insertion at middle, you need to be concentrate. Okay, see, first I need to take the struct node, right? Let me take out here, let me take out this one, let me copy and paste it here. Hold a minute. Yeah, I am taking a structure node nn and a temporary pointer p. Now I created a this one, right? Struct node star mlock means I created some memory to that. Okay, hold on, I need to put semicolon here also. No semicolon, no semicolon. Yes, is there anything? Yeah, here I need to put a semicolon, here I need to put a semicolon. Is there anything I need to put? No, nothing. Yeah, here I need to put the semicolon. Okay, now memory has been allocated. Now I need to know the position, right? Where the position to insert. So for that, I am going to read the position, and I am going to take a count flag. Okay, hold a minute, let me take a count flag. You can take anything. Okay, let me take count flag equal to 0. Now what I'm going to take do means, first I need to read the position at printf enter position to insert. I'm going to read the position. Okay, done. Position has been taken. Now what I need to read, right? Scanf percentage d ampersand of pos means pos variable will hold the position. At what position I need to store the data, like that. And then what I need to do, I had created some memory, right? And I need to store the data. And then of data equal to the element I'm going to store. Once the element has been stored, I need to start from the starting pointer and see while we reach it to that position or not. I will check it. While p next means while reaching to null, you need to go like that, right? One by one node you go, but you need to take like this. See, count flag equal to count flag plus 1 means you need to increment the counter whenever you reach one node. Okay, now while going like that, whenever you reach it to the required position, you need to stop the process, right? Whenever you reach it to the required position, you stop your process, you break the loop, and if you haven't reached to that position, you simply go to the next node. So p equal to p next. So what we are doing means, you see here, see this is a node and this is a node, this is a node like this available. Now I'm going to try to insert here. Then what happens? I will check out here whether I will reach the required position. Yes, I reached it. Then I will establish a connection like this and like this. So I will get a link, right? See, this is my linked list. Like this, we can create the linked list. Now you can see, after coming out of this loop, I will get the required position where to insert. So first I will insert, and then of next will point to p next. The pointer's next one. Next one, the p next will point to where? NN. So that a new node will be inserted at the middle, right? Now let's see the display function. Okay, we will display the entire thing. Okay, hold a second, we will display the entire thing, how we are inserting or entire linked list contents will be displayed. See, it is not taking any parameters. Let me take a node, struct node star p. Okay, a point has been taken. I am taking like this. If start equal to null means what? Start has been null means there are no pointers, there is no nodes. Then in that case, I will directly write the message printf no nodes available. Okay, I'm writing like this. And else, right? I need to write else, and I need to traverse one by one node, right? That's why what I'm going to take is p equal to start from the starting, and then while the p is not equal to null, p is not equal to null, I need to traverse, right? Let me print out the content. I am taking the integer data, right? That's why percentage %d. Let me put some dots, okay? And p of data, right? I will get the data present at that node. And then immediately I need to move to the next node, p equal to p next. Like this, we can move forward, okay? Now, in this way, we can able to display the entire content, okay? P equal to p next and get the next node data, again next node data. I consider integer data, that's why I use the format specified as percentage %d. See, this is our node, the integer data and a pointer. And then I consider the beginning code, ending code, and insertion of the middle code. Now let's see what will happen. Let me save this and let me execute. Let me compile and run. Okay. Okay, we got some error. Okay, this is a semicolon I should put. Okay, now one more time, we will check it out. Break, semicolons need to be kept. Okay, semicolon, semicolon. Again, yeah, insert at end. What is the thing? Insert. Okay, there's a spelling mistake. Insert at end, insert at begin, insert at middle. Yes, good. And one more, any observations we will see. What was that? That insert at begin. You can see here, right? Insert at, okay, insert. Okay, this function name insert at begin. Insert at end. Okay, insert at middle. Good. Now let me execute. Let's observe. Yeah. Can you able to observe? The choices has been appeared here, right? You can see here the choices has been appeared here. Insert at begin, insert at middle, like this, right? Okay, I need to update the choice. See. You can see there's nothing, no need to worry here. I type at 2 times insert at end. Let me give the third choice as insert at middle. Okay, and let me execute one more time. You can see begin and insert at middle and display. Now let me give the display option. See, you can see no nodes are available like that. No nodes are available, right? Again asking for us to take some content. So let me insert at begin. Now see, insert, enter element to insert. I want to enter the element. Let I'm going to insert 10 as a data. So enter your choice, right? I'm going to take the 4. So you can see the data is 10, right? Yes, and again it was asking for us the data, right? It was asking for us. Now you can see, okay, I will insert at end. Okay, the second choice I'm going to take, enter element insert. Let me take the element as some 20. Okay, 20 has been inserted, and let me see whether 20 has been inserted or not. See, you can able to see after 10 at the ending 20 has been inserted, right? You can able to see that. And let me take the choice, guys. Let me take the choice as some again insert at beginning again. See, I want to insert 5. Now let me print the display function. You can see now the 5 has been inserted at the beginning, right? Initial linked list is 10 and 20. 5 has been inserted at the beginning. Now again take insert at end, and I'm going to take, hold a minute, let me scroll up, insert at end, and I'm going to take an element as some 30. Let me display it. Okay, you can see the 30 has been added at the end. You can see the first linked list is 10, 20. I added a 5 before it, and I added 30 after it. Like this, we are performing insert at begin and insert at end operations. Now let me perform the insert at middle operation. Enter element to insert, right? Let me give the element as some 15, and then the position is, let me give the position of the second position, and it has been inserted. Let me check out. See, 0, 1, 2 at the second position, the 15 has been inserted or not? Yes, we can able to see. Now what is our final list? You can able to see the final list. See, 5, 10, 15, 20, 30. I inserted at the begin, I inserted at the end, I inserted at the middle using the codes, right? You can see the code. The code is this one. I call the cases, right? I call the choice of the user, and whenever the user has chosen his choice, then I am going to invoke insert at begin function, insert at end function, and insert at middle function, right? As we discussed how to handle the pointers, with that we can able to create the linked list as per our wish. Okay, this is all about the insertion operation, and you need to practice this type of things with the pointers. Okay, thanks for watching, guys. Please do like and subscribe to our channel for more videos.